Yeah, yeah. This probability and statistics is the paper. So entirely, this paper is divided into 5 parts. Module one is basic probability. What is the definition of the probabilities and what is conditional probability and its applications. And the second topic is random variables. I'll go for the module two, the basic statistics and discrete probability distribution. So what is a random variable, and we'll discuss what is the discrete probability distributions of this thing. I will go for the module 3, the continuous probability distributions and bivariated distributions. And the fourth topic is curve fitting and correlation, and this another topic is regression is also there. Next, we'll go for the fifth topic, applied statistics. In that one, we'll get the sample space, small samples, large samples. So how to test the samples data by using the samples, all these things we'll discuss here. So before going for the topic, first of all, we'll say what is the probability and what is its necessary. For example, when if I am doing an experiment with identical conditions and with homogeneous results, if the outcomes of the experiment are unique, then it's called a deterministic experiment. If the outcomes of an experiment are more than one outcomes, then it is said to be predictable, unpredictable deterministic. For example, if I'll take a circle R with a radius R, then if I'm asking what is the radius of the circle, then say we can easily we can say so the circumference is 2 pi r. What is the area is of the circle with r is the radius, then we can say pi r square. But if I'm asking, for example, another experiment I'm doing, if I'm tossing a coin, so what happened? Two outcomes are there. So if you're tossing a coin, one is a head, another one is a tail. Two outcomes will get. In the first case, if I'm saying r is the radius of the circle, then we are saying it is circumference is 2 pi r and area is pi r. So the outcome is unique. But in the second case, tossing of a coin, what are the outcomes is not unique. The outcomes are two outcomes I'm getting. One is head, other one is tail. Now we'll see the this is the we'll say started with that means when the outcomes are more than one, then we go for the what is an event is we expected, that event we are predicting quantitatively. So that is called probability. So if I'll go for the module one, the basic probability and random variables, the probability spaces and conditional probability, and we'll see the different kinds of the probability definitions and different types of the probabilities, and very important is the base theorem is there. So this is we'll see in detail later. So and if we go for the random variable is another concept. So random variable actually it is a function from sample space to set of real numbers. So there are two types of the random variables. One is a discrete random variable and another one is a continuous random variable. So we'll discuss these random variables in the next session. So and there are two types of the random variables. One is discrete and another one is continuous random variables. And we'll see what is the probability distribution of this one and some problems on random variables. And after that, I will go for the movements and variance and some of the variance sum and the Chebyshev theorem and this entire first. So this is comes under the basic probability and its properties. So entire we'll discuss in the unit one. So first of all, I will go for the what is the basic definition of the probability. Before going further, so first of all, if I am doing an experiment, what are the results I will get? Those are called outcomes. But when I am doing an experiment, it should be identical condition and homogeneous should be there. Then only we'll go for the it is said to be random. Now we'll see what is the outcomes. For example, tossing a coin, the outcomes are head and tail. But here, when the condition should be same, that means whatever the possibilities of the head should be equal to the possibility to get the tail should be same. Then the experiment is said to be unbiased experiment. Now we'll see. Next definition is sample space. What is a sample space? A set of outcomes of an experiment is called a sample space, and it is denoted by S. For example, if I am tossing up two coins, so the outcomes may be both coins are heads, both coins are tails, one coin is head, one coin is tail, is one head tail or tail head. That means total four outcomes I will get. Those are head head, head tail head, and tail tail. So these are the four outcomes also. So each outcome is called an event. Now, what is the sample space? Sample space means the set of all outcomes of the, I'm considering it as a set, then the set is said to be a sample space. When tossing up the two coins, now we can see the sample space is equal to head head, head to tail, and tail head and tail tail. Now we can see what is the random experiment. As I said, random experiment where outcomes is not unknown, they are not in advance. So the outcomes of the experiment are called random trial or random result, will say. Outcomes are known as elementary events. Whatever the outcomes so I will get, those are called elementary events. That means tossing up a coin, getting up head is one event, getting up tail is one event. These two are called elementary events. So what is a trial? Trial is each performance in a random experiment is called a trial. So in experiment, whatever the performance we are doing, that is called a trial. The result of the random experiment are called outcomes. So if the outcome is one outcome, if there are more than one outcomes. What is an event? Every non-empty subset of a sample space of a random experiment is called an event. For example, so if I'm doing this one, tossing of two coins, the sample space is head, 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 tail, tail, head, and tail, tail. This is the sample space. Any subset of the sample space is called an event. Now, another example, if I'll go for the random experiment, tossing of a die. A die has six spaces, so consisting 1, 2 dots, 3 dots, 4 dots, like the 6 dots are. So, if what is all possibilities of the getting this outcome should be equal, then the experiment is to be random experiment, and the events should be equally likely. That means the occurrence of the every event is should be equal. Now, so this possible outcomes to the random experiment, the observations are 1, 2, 3, 4, 5, 6. So the total outcomes when I'm tossing a die, sorry, rolling a die, the outcomes are 6. Sample space consists 1, 2, 3, 4, 5, 6. Similarly, if I'm doing one more experiment, tossing of, rolling of two dice. Rolling of two dice, one first die is consists 1 to 6 members, and the second one is also consists 2 members. So total how many outcomes I will get? 36 outcomes I will get. That means 1, 1, 1, 2, 1, 3, 1, 4. That means on first die it shows 1, second die is 1, first show 1, 2, 1, 3, 1, 4, like that. I'll get 36 outcomes I get. The sample space consists 36 outcomes. For example, if an experiment I am doing, it's out this the experiment it is with n phases. The number of units I am using is r, then the total number of outcomes are n power r. For example, if I am using a die, two dice I am using. So each die consists 6 spaces, and I am using 2 dice. So the total number of outcomes is 6, 2, 6 power 2 is nothing but 6 squared. Now, tossing of two coins. So the outcomes are 2 coins, 2 power 2, 4 outcomes I will get. Similarly, n phases, r units I am using, then